So my name is Lisa von Rössing, and I'll present towards damage prediction, mapping the inspection history of concrete bridges. Images and statistics such as these have become very common, especially in industrialized nations. So the first one, I think we've seen it today already. It's the collapsed bridge in Dresden. And then we have a statistic from the US where just in the state of Pennsylvania, they found that 12,000 bridges or more than 12,000 bridges are in need of repairs soon. And in Germany, 2,200 highway bridges have the rating poor, which is the worst rating they can get, which means they really should be fixed soon. And then we have a statistic from Japan where nearly half of the bridges that they have, from the ones where they know, will be aged 50 years or more. And all of this means that we need maintenance, and we need this maintenance to be effective and well-timed, because obviously all of this costs money, and we don't have money growing on trees, so we want a good strategy to achieve this maintenance well. And we want the strategy to be effective and efficient, and to do that, it would be really good if we can anticipate deterioration. If I know how my bridge will behave or deteriorate in the next 5, 10, 15 years, I can plan my maintenance accordingly and anticipate it, plan the correct measures, and so on. To plan this strategy, I need information. And obviously I want good information. I want this information to be up to date. I want it to be accurate. I want it to be reproducible and objective, so reliable. And where do I get this information? We have inspections. So in Germany, there's a specific regulations, and I think in most other countries, there's regulations for this as well. And to get this whole pipeline of maintenance, we want good inspections. So that's why we decided to look at the common tools that are used currently to improve this inspection process so that we can provide this good information. First of all, we have artificial intelligence. So we have something for processing large amounts of data. We have building information modeling for data collection sharing, and we have augmented reality for visualization information. What we have found is that we also have a large amount of historical inspection data, and that's not used a lot. So it could be used to anticipate what happens in the future, because obviously I need data, I need to look into the past to see what might happen in the future, but it's actually used quite rarely. So we found 2 instances where textual data was used. Once it was mapped to IFC components, and once it was mapped to components in a direction. So let's say you have a beam and it's at the top of the beam or the bottom of the beam. However, for example, the images weren't used at all. And we found also in the research that having a 3D model where all of our data is listed, where it's actually localized, so I can check, oh, this is where my spalling instance is, would be really helpful to inspectors. And also to provide this historical data in an analyzed way so that inspectors can use it to anticipate deterioration, to do the inspection accordingly, would be really nice. So that's what we wanted to do with our study, to create a holistic concept of accurate mapping of historical inspection data, to also help with analysis and prediction of damage progression. So we call the concept bricks. It's a long story, but we focus on effectiveness and feasibility. And we created this concept in 2 steps. So first we did a state-of-the-art review. So we consulted literature, current projects, and we looked for possible solutions to these issues that we had found, but also for gaps and limitations. And we focused on this data that we have in Germany. So we have a text with a rating and we have a picture. And we looked for studies that considered the same type of data. We also had a look at the requirements, so both from regulations and also from expert interviews, because we wanted to consider the technological and legal requirements and also the experiences that inspectors can provide already so that we can actually assist them correctly. From that we developed this concept, and then in a later step we'll also develop a demonstrator so that we can validate what we have created as a concept. Let's get into the concept. As I said at the beginning, having such a damage map would be really nice, because at least in Germany right now, inspectors get a paper report that says, oh, there's spalling, here's a picture from 2005, good luck finding this. And it would be really good to have more than that. And what we have were these damage images. And what's like a little bit of effort, but it's still easy to get, is a LiDAR scan with panoramic images. And I can match these 2. So my colleague developed a Python module called Lilac. It uses the fingerprint. So if you look at concrete, it has like a few markings, a few holes, and you can use that for matching. So we do feature extraction and then key point matching, and we can match these damage images into our LiDAR scan. And from that, we can create a damage map. And then, if you're an inspector, you can use this damage map to find out, okay, where are my damages? Do I need specific equipment to access them? And I can make informed decisions for planning my inspection. Now you are on the bridge, you're an inspector. What do? We support you with a tablet which has AR and AI functions. And if you want to find a damage, first we can help with finding this damage. In the first step, we only do detection, because if you're just going around with the AR tablet, you don't need to know the size of the damage. But later on, we can also do segmentation. So if you take a high-quality picture, we can create high-quality segmentation. And then, as I said, we wanted to assist with the prognosis. So we also have old data, and we have an old mask. And using this Python module again, so liloc, we can match that and subtract the old mask. So we can only mark the changes, and the inspector can really easily see what has changed. Obviously, I mean, someone mentioned already, it would be really nice if we know how large this damage is. That's difficult because for the old data, we don't have any idea. But what we can do is we can count the pixels and the change. So for this example that I showed, I can say, okay, if I take the picture from 2005 as my initial starting point, I can take the pictures from 2017 and say, okay, we have 30% more pixels. And we can see, okay, it's gotten larger. If this keeps going the same way, where might we end up in 2029, where the damage might be double the size as it was before? We collect all of this data, we provide the inspector with it, and within this app that we have, we also do some more things. So like, which category of damage could it be? We have 300 different ones, so it's a bit much. But in general, the inspector has to pick, so we're still counting on humans to pick out of all of these damage types, and they can review all the information that we have as needed. You can also export it to the bridge management system, which is required in Germany. And if someone has a digital twin, it would be really nice if they can also use this information. So it's modular, and you can just export it the way you want and the information that you want to include it into a digital twin as well. That was the concept, so let's get to the strengths and limitations. In general, this project builds on a previous project, which was called Bridge Inspect or BIS, and this has already received good feedback. So we've tried this whole, you detect the damage with AR, and you can pick a category before, but we wanted to extend this, especially with considerations for prognosis and further state-of-the-art technology. Many parts of this concept have already been proven individually as well. So for example, this idea with overlaying mask was already tested in the UK. I forgot the name of the researcher, but it's in the paper. What we still want to do is we want to test the concept in full. So we have all these individual little steps, but we want to make sure that it actually does support the inspectors and how much it supports the inspectors. So can we quantify which improvements we have made, and can we make it even better as well? And then we come to my favorite point, which is that we lack data, which means that we are limited in implementation and training. So as I said, this is what it looks like, and you can sometimes get this data in a paper report, but it's really hard to get more of this data, although it would be really interesting because we have a lot more ideas that would be great for prognosis. So for example, here you have a rating, and the final number, this D, is for durability. And it would be really good if we could assist inspectors with rating the durability, or if we can show more data on what has changed. So maybe I have 10 different points in time where I have this durability rating, and I also know how a type of spalling is changing usually, and I can tell the inspector, okay, I think the next year it's going to be fine, oh, someone really should look at this. But we haven't got the data to actually try this. So we have a few ideas, and I wish I could tell you more about it, but right now we haven't been able to try this. Let's get to the conclusion and outlook. So in summary, we developed the BRICS concept for improvement of structural inspections using historical data and state-of-the-art technology. And we want to support inspectors in assessing damage quickly and uniformly, and also support this prediction of impact on durability. The next steps are a demonstrator. As you can see, we've already started working on a demonstrator, and further methods. So we're really hard at work on getting further data so that we can add further methods, such as, for example, a description by a large language model of an image to assist with the classification further. And then, thank you very much for your attention, and I'm open for questions.